So I'm Rob Burnett from GE Transportation, and basically my job is to implement and support systems and infrastructure in our transportation manufacturing facilities in North America. I don't know if any of you guys have seen the new GE ads lately about GE Digital and GE Software, where Owen tells his parents out of college that he got a job working for GE, and his father gives him the hammer that he can't lift. That's kind of like me. I work for transportation, but I don't build locomotives. I build software and systems. So before we go into what digital thread means across GE and what it means for transportation specifically, I wanted to give a little background on my business unit. So at transportation, we're known for highly fuel efficient and emissions efficient products, mostly. So we make locomotives, we make mining vehicle propulsion systems, we make engines that go into marine and stationary and drilling applications. And then we offer a wide variety of services, of overhaul services, repair services, we even offer power as a service for some of our locomotive customers where we actually own the assets and maintain the assets for them, for a price per power type of agreement. And then obviously with some of the new direction of our company going forward, it's about software. So we make software that's on our locomotives. We make software that's used by our locomotive customers across North America that helps them efficiently move product from one place to another. And now we're moving a lot more into software for manufacturing. So a lot of the products that are being developed by our GE Digital business are being applied and used in our plants, and we're helping to progress that as we move forward. So this is Digital Thread is really an initiative that goes across all of GE. All the GE businesses are attempting to invest in these technologies, invest in systems, and to connect their business throughout their product lifecycle. In transportation, that means we've got a long cycle business. Our locomotives can be in service for 20, maybe even 30 years. And for our business to make a lot of money in services, we need to understand what's on those locomotives, what are the operating conditions of those locomotives. So we have a very sensor-enabled product. We have thousands of sensors on our locomotives that we're collecting the data, and we're trying to optimize the performance of that for our customer, but we're also trying to predict how to service the locomotives better. In order to do that, we had to integrate a lot of our applications and systems. So one of the good things about our business is we started this journey several years ago, standardizing our ERP systems, standardizing our MES system, standardizing our quality and maintenance system. So basically all of our plants are running on the same systems, and we can very easily integrate those together. The next thing that we're doing a lot of is censoring our machine tools. I heard some great presentations earlier today from Mazak and others about how to actually optimize the equipment that you have in your plant that maybe you're not an expert on. So we're learning, we're doing OEE, we're connecting, last year we connected about 150 different machine tools, critical pieces of equipment that we think is potentially bottlenecks when we were in a record production year. And we intend to take that to over 400 machines by the end of this year. And then we are also implementing data analytics throughout the product lifecycle. So we've invested a lot in reporting and in business intelligence and analytics from the design engineering into our manufacturing plants, looking at sourcing and quality information for our suppliers, into field services, and then back into our repair points. So that's a really big deal on how we're actually able to pinpoint where our improvements can actually happen. And the remanufacturing and services is really the best part of our story, and I think that's what differentiates us from some of the other presentations and concepts that have been shared earlier. So if we can figure out how to increase the life cycle of particular parts and wear and tear, that means a lot for us, and it means a lot for our customers. So we have systems in our repair points where when a locomotive engine comes back in, we can look at the serial numbers, we can look at the last time it was serviced, we can see the operating conditions of that asset, and we can actually use logic to figure out what repairs should be done and what shouldn't be done. And that saves us a lot of money over the life cycle of a long service product. So here's a little bit about how we did it. It started with a great foundation. So of course I'm the IT guy, so I get to talk about the infrastructure we implemented, but I think it's fundamentally important because we wouldn't be able to connect hundreds of machines and do massive amounts of data collection without this foundation in place. So it started with a secure IT architecture for the shop floor. So we partnered with Cisco, we partnered with a lot of IT security experts, people like World Tech, in order to help define what this is and then create a standard across GE that we're implementing in many of our plants right now. But we helped create that architecture. We believe it's scalable from the edge all the way to the cloud. So a lot of people, of course, are talking about cloud. It's a major trend right now. We believe that there still has to be a good level of intelligence and closed loop control at the edge. So, how we're using PLCs, how we're programming things at the edge. And then we have basically plant-wide collector systems that can replicate their data to the cloud, where we can do some more horsepower and analytics. And then at the cloud level, we can merge that locomotive RMD data, and we can merge other sources of data from other applications and systems and do some very high-powered analytics. We also were able to figure out a way to do secure connectivity. So we've talked to many people who offer remote monitoring services on a particular machine tool, similar to like what Mazak presented in the session earlier. That's great. We need that help. It's not always about preventing downtime. Sometimes it's about getting that machine up and running as fast as you can when it does go down. And in order to do that, you need a secure way for those vendors and OEMs to come and look at your data in a way that you can trust, and you're not opening yourself up to too much risk. So we've established some infrastructure that allows us to do that securely. And then, also fundamentally, it's the IT and OT convergence, and how do our groups work together to go accomplish these projects. We did some really great work early on in defining those roles and responsibilities and working together as a team to go connect machines, build the architecture, build the system, then ultimately achieve the business outcomes. So one of the biggest problems we had, especially in our remanufacturing plants, was visibility to our process and visibility to our costs. So when you are remanufacturing engines that can be 10, 20, or 30 years old, when you start spotting a trend of, hey, this particular component is scrapping more than it was, the last 5 years, the quicker you catch that, the quicker you can do analysis on it, the quicker you can get that in your hands of engineering is really, really important. So we spent a ton of time on the shop floor just watching these kind of, old school paper processes. And we developed an MES system that captures quality information, measurement information, standard kind of discrete manufacturing features around, takt time and collection of actual labor versus standard labor. And we built it into an MES that has a very contemporary interface. It's on iPads, it's touch screen. We're not in the days where we have to have an operator go and walk over to a kiosk to punch in a bunch of information when they finish their work. We're doing it very real time, on a mobile device at their workstation. We have also done a lot of integrations I talked about integrating 150 machine tools. Where the really brilliant stuff comes in is when you start to actually integrate that into your MES. You can stop a line when somebody hasn't finished an operation completely, like maybe torqued, the bolts to the full specification. You can prevent that product from escaping, going to the next workstation, potentially harming or hurting somebody. So we've built those integrations in a few cases, and we've been able to see some significant improvement and some good quality metric improvement on those projects. We intend to increase that even more as we go further and connect more machines. And then lastly, our plant managers had this vision of, kind of the single pane of glass. I don't want to have to go to an MES system and answer all these questions, go to a quality system, enter a bunch of measurement information, go to an ERP system and do material transactions. So we basically let the MES be the front end, and we built some interfaces to those background pillar apps to make it truly simple for the operators. So some examples where we've actually connected the digital thread. I'm not going to act like we've done. I mean, it absolutely is a journey, but these are some of the things that I think are pretty cool and are worth sharing to a group like this. So we have an application for field services that tracks all the maintenance of an actual locomotive, and in this system we have things like overhaul hours and the hours that the locomotives have been running, any warranty information, any damage information. We now feed that into our MES when we do a teardown. So before the operator even starts to take anything off the locomotive, they're able to look at individual hours of certain parts that are on that locomotive and determine what work needs to be done using an algorithm and using logic. That actually feeds us the ability to skip certain workstations, whereas before, just a couple of years ago, we would tear everything down 100%, requalify the parts, throw out the parts that were not able to be requalified, and then rebuild the engine. So there's obviously a lot of labor and part productivity that you can capture by doing something like this. And then lastly, we feed a lot of that real-time information around scrap or certain types of wear and tear or certain type of damage back to our engineering teams. We absolutely want to eventually feed that all the way back to design engineering, but really more looking at it now from our manufacturing engineers. Should we invest in a robotic welding tool? Should we invest in additive manufacturing? If we did that, how many more parts could we save that had that particular type of failure? We capture all that information in our MES system, and we're using it to do continuous improvement. So lessons learned. Buy-in on this and the change management of taking on something of this scale is huge. So fortunately, we have a CEO and CIOs and CEOs of our sub-businesses that are all about this digital thread, and that's what they're talking about whenever they're talking to investors, whenever they're talking to suppliers and customers. There's absolutely no doubt that across the company we're bought into this. But bottoms up is really where I think some of our lessons learned really came from. We put TVs on the shop floor displaying some of this MES data, displaying some of the manufacturing machine data. And we didn't, it wasn't like we thought would happen where everybody saw it and thought it was great and wanted to help and improve the metric. I mean, we really had to spend some time talking to the operators and saying, do you understand that metric? How does that influence your day-to-day job? Can you see it? Is it useful to you? And we tweaked it as we went, and now actually we found out that, at least in our plants, maybe the TVs aren't the best way to show the metrics. We prefer now to look at how do we just show it on the iPad. So as I'm signing off on doing my work, I flip over and I can see, progress and goals on the day, shift, week, and I know exactly if I'm ahead or behind. I can flip my and-on light. So we're starting to put more of that in the hand of the operator and really enabling the operator, but that took kind of a learning curve and kind of tweaking our approach and pivoting as we spent a lot of time with them, watching them use the system or watching them not use the systems. And I really think it starts with building a great team. We've got some great partners from our OT function, but also partners externally. Some of our integration providers that we've partnered with, some of the machine tool makers that we've partnered with, our global research center. We're taking on something that's new for us, and recognizing that we didn't have the skill set, so we couldn't learn it and do it all ourselves was a big deal. And then it was all about outcomes. I think early on when we implemented some of the systems, we didn't do a good enough job of actually publishing the metrics and letting people know, hey, here's the improvement that we're having. And once we actually put some of those metrics in the hands of our plant managers and our production leaders, that's when we really started to drive the adoption and drive the buy-in. So my advice there would be don't wait to publish the metrics later. Don't put the system in and then wait to do the reporting and metrics later. Do it all in one go and start enforcing the right behavior right out of the gate. And then it's a journey, so expect challenges and persevere and continue to learn from your peers and crowdsource ideas wherever they may come from. So in summary, that's our journey for Digital Thread. It's continuing. We've had some great wins, but we won't stop. We're going to continue to invest in new technology. We're working a lot more on our engineering. I mean, eventually we want to be 100% model-based, not just for our designs, but even through some of our as-serviced. I think there's a huge opportunity in what we call the digital twin, which is a model of what's on every locomotive in the field that we can feed back into some of these systems for better forecasting and engineering design changes and simulations. That's all I have. Thank you.